Chapter 13, Surface Area and Volume. The topic is frustum of a cone. What is a frustum of a cone? So it is something related to the cone. So see, we have a cone here. When we have a plane which is parallel to the base of this cone, it is cutting into two parts. One part is clearly a cone, other part is known as the frustum of a cone. So when we slice a cone using a plane parallel to its base and remove the cone that is formed on one side of the plane, and the part which is remaining left over is known as frustum of a cone. What's a frustum of a cone? When we have a plane parallel to one base of the base of a cone and it slice or cutting into two parts. One part is clearly a cone, other part is known as the frustum of a cone. So what we have to learn is clearly the volume, CSA, TSA. So we have to by heart the formulas. The CSA of the cone is pi into R1 plus R2 into L. Look here, this is the frustum of a cone and this is the height. So two bases which are of circular part. So the distance between both the centers are known as the height. So that is the height. This is the lateral length or slant height and radius R1 and R2. So the formula is CSA is equal to pi into R1 plus R2 into L. What about the cone? CSA pi RL. Here instead of R we are using R1 plus R2. Then L. What is L? Root of h square plus r square there. For a cone, here what we are using? L is equal to root of h square plus R1 minus R2 whole square. L is equal to root of h square plus R1 minus R2 whole square. Then TSA, this part CSA plus two circular part. So CSA is pi into R1 plus R2 into L plus here pi R1 square, here pi R2 square. So pi L into R1 plus R2 plus pi R1 square plus pi R2 square. Then volume. Volume is 1 by 3 pi h into R1 square plus R2 square plus R1 R2. Volume is 1 by 3. There for a cone it is 1 by 3 pi r square h. Here instead of r square what we have is R1 square plus R2 square plus R1 R2. You have to by heart all these formulas. Then we can start doing the first problem. The first problem, exercise 13.4, first question. A drinking glass is in the shape of a frustum of a cone of height 14 centimeter. The diameters of its two circular ends are 4 centimeter and 2 centimeter. Find the capacity of the glass. Capacity means we have to find the volume. What is given? First you have to write the given things. What is given? H is equal to 14 centimeter is given. Then diameters of its two circular ends. So both the radii are given. So R1 is equal to 4 by 2 which is equal to 2 centimeter. R2 is equal to 2 by 2 which is equal to 1 centimeter. We have to find the volume. What is the volume? Volume is equal to 1 by 3 pi h into R1 square plus R2 square plus R1 R2. We have to substitute the values. So 1 by 3 into what is the value? Pi? 22 by 7. 22 by 7 into what is h? 14 into R1 square. 2 square plus 1 square plus 2 into 1. So we can cancel 7 and 14. We will get 2 there. So it is equal to 22 into 2 into, what about this? 4 plus 1 plus 2 divided by 3. So it is equal to 44 into 7 divided by 3. So when we have, so we have to find the value. The value is 102 2 by 3 centimeter cube. Everything is given in terms of centimeter. So centimeter cube it is, because it is volume. So we have used the formula directly. What is the formula? Volume is equal to 1 by 3 pi h into R1 square plus R2 square plus R1 R2. So h is given, R1 is given, R2 is given. So we have substituted the values in this equation. So we got it as 102 2 by 3 centimeter cube is the capacity of the frustum. Next question, exercise 13.4, second question. The slant height of a frustum of a cone is 4 centimeter and perimeters or circumference of its circular ends are 18 centimeter and 6 centimeter. Find the surface area of the frustum. Find the surface area of the frustum. We have to find the total surface area of the frustum. Okay. So what is given? What is given? Slant height is given. L is equal to 4 centimeters and 2 pi R1 is given and 2 pi R2 is given. So 2 pi R1 we can take it as 18 centimeter and this we can take as 6 centimeter. So 2 into 22 by 7 into R1 is equal to 18. We can find R1 from this and R2 from this. So R1 is equal to 18 into 7 divided by 2 into 22. Cancel this, 9, 63 by 22 centimeter is R1. Then we have to find R2 using this relation. 2 into 22 by 7 into R2 is equal to 6 centimeter. So R2 is equal to 6 into 7 divided by 2 into 22. Cancelling this, we are getting 21 by 22 centimeter. So we got R1 and R2. We got R1 and R2. So what do you have to find? We have to find the surface area of the frustum. So it is pi L into R1 plus R2 plus pi R1 square plus pi R2 square. So we can find CSA first. What's the formula for CSA? What's the formula for CSA? It is pi into R1 plus R2 into L. Pi into R1 plus R2 into L. So it is equal to 22 by 7 into, what is R1? 63 by 22 plus 21 by 22 into L. What is L here? L is given as 4 centimeter. The question is to find the CSA of the frustum. So we have to find the CSA only. So we can find this as 22 by, or write this as 22 by 7 into 22 is common. So we can add this 84 into 4. So we can cancel 22. So we are getting 84 into 4 divided by 7. We can cancel 1, 2. So it is 12 into 4 It is 48 centimeter square. So here what is given? The height, the slant height of the cone is given, which we have taken as L, which is equal to 4 centimeter, and the perimeters of the circular regions are given. That means 2 pi r1 and 2 pi r2 are given. From there we got r1 and r2. We got r1 as 63 by 22 and r2 as 21 by 22. The question is to find the CSA. CSA means pi into r1 plus r2 into L. So we have substituted 22 by 7 into 63 by 22 plus 21 by 22 into 4. So when we add that, we got it as 84 by 22. So we can cancel off both the 22s. Remaining we got as 84 into 4 divided by 7, which is equal to 48 centimeter square.